In this video, I'd like to talk about the zeros of polynomials, specifically looking at a concept called multiplicity. And before we look at any of these example problems from the Khan Academy, let's look at our own example. So I've drawn this coordinate plane, but let me just create some type of polynomial function, and then we'll look at what the potential equation for that polynomial is, and we'll talk about what this idea of multiplicity is. So we have this orange curve here, and let's just call it f of x. And we could write f of x as a product of linear factors. Since notice, we know when the function is equal to 0. So these points here, here, and here, these are all what we call the zeros of the polynomial, or the roots. And basically, that's when the y value or the function value is equal to 0. And from these zeros, we can determine what the equation for this polynomial would be, or what a potential equation of this polynomial could be. And so if we look at our graph here, we can see that this is when x is -5. This point right here is when x is 2, and this point right here is when x is equal to 5. Now, what we want to notice is that at these three zeros, for -5 and 5, the function will just go straight through the point. But at this point, x is equal to 2, notice that the function comes down and just touches the graph there and then goes back up. This 0 is a little bit different than the other two. Namely, this is what we would say is a 0 of multiplicity 2. And let's write this function as a product of these linear factors. So we know that for this one, it would be x plus 5 for our linear factor, since you can imagine if you plug in -5 here, you would make this factor 0. Likewise, for x equals 2, we would have x minus 2 for our linear factor, since if you plug in 2 here, you would get 0. And we're just using our zero product property, whatever is multiplied here. If one of the factors is 0, then everything is 0, since 0 times anything is 0. And for this last one, we have 5, so that linear factor would just be x minus 5. Now, this equation is not complete because we're not taking into account the multiplicity of this 0. So we would say when x is equal to 2 for this particular 0, that it has a multiplicity of 2. And essentially what that means is that this is a double 0. And effectively, it's the solution to this polynomial equation twice. Or it will make the function, this polynomial function, equal to 0 at 2 different times, in a sense. So for multiplicity 2, we're going to write this as x minus 2 squared. And in reality, you could just write it twice, x minus 2 times x minus 2. And of course, we would have the other factors as well, just to complete this. So written this way, it's more clear that the value of 2 would make this term 0 and this term 0, which is one of the reasons why we say this is a double 0. But in general, if it has odd multiplicity, so these right here and right here, this we would say has multiplicity of 1, and same with this one. And in general, when it has odd multiplicity, it goes straight through. And when it has even multiplicity, it comes down and touches it and then goes back up. So we can generalize this, like I mentioned, when we can say for odd multiplicity, the function goes straight through. So again, the function is just going to travel straight through, going from either a negative to a positive value, or vice versa, in this case, going from a positive value to a negative value at that 0, whatever that particular x value is. And for even multiplicity, it's going to come down and touch it, but then turn around and go back in the other direction. So in that case, it will not go through the 0. It will only touch the 0. So this even multiplicity, the function will touch y equals 0. It will come down and it will touch this point, but then it will reverse and go back the other direction. So we can finish saying this, but we'll reverse and go back the other direction. And we can generalize this even further. Let's look at specific multiplicities. So let's say we have multiplicity of 1, 2, and 3. So let's say for 1, for 2, and for 3. And we could look at 4 and 5 if we want. But for a multiplicity of 1, let me just draw in a very simple coordinate plane for each of these. For a multiplicity of 1, the function will go through in a linear fashion. So it won't curve. If we look very close to the function at that 0, it's not going to curve, it's just going to go straight through it. However, if we look at multiplicity 2, where it comes down and it just touches the graph and goes back up, and if we look close to that 0, it behaves like a parabola or like a quadratic. And for multiplicity 3, it's going to behave like a cubic at that 0. So the function will come and it will curve a bit and kind of wiggle its way through it. That's not the best looking cubic. Let me try again. So it's going to come up, and just like the cubic parent function, it will curve a bit as it goes through that 0 there. So we can say that at least very close to that 0, the function behaves like a cubic polynomial. And you can imagine for multiplicity 4, it will behave like a quartic polynomial, which really is very similar to a quadratic, just a bit steeper, skinnier. And for degree 5, it will behave like a degree 5 polynomial, which again looks very similar to a cubic, just a little bit steeper in how it wiggles there. So we'll keep that in mind as we go through these example problems, but at this point, let's try and do some practice.